And welcome back to another exciting episode of Program Manager's Guide to Kerbal. In this episode, we will be launching a few rockets for missions and scientific research so we can get into those exciting missions that really amp up the creativity and the program management side of the house. For example, we have 6.5 science, and I'm going to take a look real quick to see. I think we need more like 20, 18, and 15. So survivability is our next plan of attack. So on this one is when we get the heat shield. So we won't be able to do that second one until we get some science. And there's a couple ways we can do that. Remember, this would be the early stages of a space program. So back in here, we need a command module. We have the onion or the reentry, the onion reentry module, and of course the MK1 command pod. Both are 615 Kerbal dollars, if you will, and both have the same specs essentially, except for mass. So the mass is, if you take a look at the onion reentry module, our mass is a little bit less at 0.77 tons, whereas the MK1 command module is 0.8756 tons. All these specs are going to be useful down the road. For example, your impact tolerance for the MK1 is 14 meters a second, whereas the impact for the onion is 12 meters a second. And that's how well we parachute, where we deploy that parachute, and how hard we're coming down. So there's always going to be consideration with that. So as a project manager in Kerbal, we have to do the command pod first. So once we have this, we're telling the Kerbals this is where we need to focus all our builds off of. And we can go ahead and zoom in if we'd like and spin around. Here's our door or hatch. And then of course we have our flag. For this spacecraft, we're just going to put test flea rocket, because it's not going to do us any favors. It's a very simple test. We have the hammerhead and the procedural, and here's the flea over here. So we'll take the flea, we'll put it on the bottom, we'll right click, and because it's just a test, I'm going to put the thrust limiter at 0 and the solid fuel at 0. I'm not going to expend any fuel. And then I'll put an orange stripe on it, and that'll symbolize to everybody that this is not an active rocket. I'll go ahead and save that design, and I don't need a parachute for this because it's not going to lift off. We have one stage, so we're doing our checklist. As always, we want to get used to it. We don't want to do anything in the earlier stages that we wouldn't do in the later stages. And of course, we have a crew. Right now, Klaus Fischer is in the module, the command pod, but we're going to take him out and put Pilot Becker in this seat. So there, she gets a little bit more experience. It's a test thing. She'll probably be the one that goes up into to break the atmosphere first. But for this test, let's get her some experience just sitting in the module itself. Okay, so once we have that, we're going to launch. So we'll put this on our pad. Now remember what I had said in the episode previous is this launch pad is basic. It's a dirt pad. We can upgrade this for about 150,000, I think it was. I'll check after this. Right now we don't need anything. We have a little in the pilot seat. We'll turn on our SAS, just again doing that checklist for future missions. Turn on the RCS, again future missions. And our mission status right now is we're on the launch site and we need to test it. So when you right click on the flea out on the launch pad, the RT5 if you will, you'll have run test. So we're not going to activate the engine, we're just going to run the test. We've met the conditions, and then we will recover the spacecraft and be successful. We got all our funds back. We didn't expend any fuel, so expected return. This is a good time for project managers to assess the tests. And what did we use? What did we recover? What we recovered, if it was a destructive test, let's see what our budget is to test that material or do further testing on that material to see at what point it may have failed, what was the stressors on the metal, all different things we can do as project managers. If our funds don't allow for it, we can think about not doing it, but it should always be considered. And a lot of project managers and program managers alike, what I would probably ask is my team. I'd go to engineering and say, hey, successful test. What do you think? Should we test the materials that we gathered or we recovered? How are we doing? That type of thing. And get your experts involved, because the experts are going to tell you for the next flight what's going to happen. In this case, we're just seeing parameters of the flea and what occurred on the test. So when we run the test, we'll let the number crunchers crunch it and see what other types of uses the flea would have for us. From that recovered parts, we got 127,000, probably close to what our spend was. So we just hit next. She got no experience for that because she didn't fly. So we're going to keep her in the pilot seat. We need to get her as much experience as possible. Okay, so from that, we go back into mission control. We can't do this just yet. We didn't get that much science. So what we would do is take another mission that will give us a little bit more science. And here's one that says, measure the temperature of in flight below 18,000 meters near Site XZZ. So if we take that, we have to fly it over to XZZ under 18,000 meters. That'll get us more renown. I don't see any science here, so I'm going to say no to it. What we're looking for is some science, and 2 is not going to do us any good. So what I might do is cancel out. We have 7.5. As you remember, I need 15 for that, so I need at least another 8. So what do? We're going to, in Kerbal, you can use your rocket to detect other biome temperatures and take scientific data, like a crew report, in those biomes. So what we'll do is we'll do that. We will need a pilot. I don't think I have any scientists. I do have a scientist. Ooh, you know what? I'm going to switch out to my scientist, and we're going to build him a rocket that'll get him to a different biome. Now, there's a couple different ones here, and we do have liquid fuel rockets. Liquid fuel, I'm not going to really need it. What I want to do is, because I'm going to have extra weight and I won't be able to decouple, I'll probably stick with the flea because I just need to go to the ocean and do a splashdown in the ocean. This whole capsule and the RT-5 will float. So we do our checklist. We have our command pod. We have our source of fuel and propulsion. So we go down through. We don't need any of these. We have a decoupler. We do have a decoupler, but we won't. You know what? I'm going to use it. So we're going to come over here. And as a project manager, these are the decisions that you'll make to add cost to the spacecraft. The stakeholders will probably be okay with this, and I don't doubt they would have any disagreement here. Once we look at this, right now this rocket spacecraft is going to cost us $935, or I'm going to say dollars. It's going to be such a interesting series. So once this cost is deducted from the 127,000, so it's decently expensive I mean, the decoupler itself, if you look at it, is about 200. So, and it's we could probably recover the decoupler. As you saw, the decoupler at this point, this is this arrow that you're seeing in the center of the screen is pointing up. That means the explosive force for the decouple is going to be aimed at the capsule. So the capsule will be ejected, not the actual rocket. Can I flip this? I can on this one. Actually, you know what? For 200, I don't need it. The flea will make it to exactly where I want to go. So I'm just going to use the flea. And I'll make sure I have, you know, and there's the project management decision. What are you going to spend and what are you going to spend it on? Personally, in this case, we don't need to decouple. And like I said, I can gather enough data from the science, and there's some scientific instruments here. We have a thermometer, and of course in Kerbal, we're going to put it on the outside. And there's a container of goo. I'm not sure if it'll give me any science, but let's see what happens at sea level. I like to balance out my spacecraft as much as possible, and there's a little mechanism over here in the lower left-hand corner that allows me to toggle to instead of being free. So I'm toggling to a grid essentially. So we're gonna, and that's the side of the rocket that is gonna be weighed down a little bit, so it'll start going in that direction. What we want to avoid is a flipping motion, because then the parachute becomes a little bit more, it'll be more in distress, and it'll have a bit higher chance of failure. So in this one, we're just gonna do generic science run. So we'll just call it a generic science run -1, and then we'll do ocean biome temp and goo discovery. So once we have that, we will choose different mission flag because this is more R&D, and that way we can keep a little bit more control. So we'll do R&D on it. It's an actual company in Kerbal, but it's kind of a cool symbol to keep so we recognize what we're doing. I'll save that GSR1. And over in the lower right-hand corner, again, going through that checklist, we have a stage now. We have that parachute. So we're going to move the rocket to stage 1 and the parachute to stage 0. Again, no need for any of these tools just yet. There is a checklist here for the engineering report. We're using 5 pieces. We have a mass of 1.477 tons. Excuse me. The 18 is the allowable tonnage for the launch pad itself. So I really have to keep an eye on that in earlier missions, because as I build bigger and bigger rockets to get further and further or different mission objectives, I'm going to have to figure out how we are going to do that before spending money on the launch pad. So we're going to look at that. We have our stages. We have our cost of 2,857 because of our science, but we're going to get, for science, I'm willing to spend the money. Recovering the science is the paramount. Now again, we're playing this game from a project manager's position, but also a learning position. What we want to do is, if this design fails, then we'll recover it from not necessarily in game time. We'll recover it and go back to the drawing board essentially. So it'll just be more of a test. Of course, in the real world, we'll be able to do this with prototypes, but destructive tests with prototypes, even though valuable learning, you still want to minimize the amount of prototypes you're using, right? Perfect example of this in real world is SpaceX. They've had close to 27 flights of their spacecraft that failed on landing several times, but they're learning new things, and those mistakes you can see are not coming up again. Their engineers are learning from the data that they're gathering from all the systems, and probably came up with a few different systems or sensors for more data gathering, so they can analyze different aspects of the flight that they weren't in the first one. So in the second one, they probably had more. Third one, probably more. At some point, they probably had enough to settle down a little bit as far as the amount of data, because you can go into what's known as data paralysis. If there's just too much analysis of data, you won't make a move. So there's a certain point where you have to say this data is superior over another type of data, and I would use statistics to find out if anything's correlated. If it has a strong correlation, maybe you look at it a little bit differently, but for the most part, you don't want to go into that analysis paralysis, if you will. All right, so we're going to launch this puppy, this spacecraft of science. All our systems were checked over prior to discussing the project management side. Now here's where it meets the road. So we're looking pretty much at our pad. What we want to do is we want to go toward the ocean, which means we're going to have to pilot this just a little bit, and we have a scientist on board. With a scientist on board, you can't toggle the SAS. So let's see how this goes. All this for science. All right, let's do this. 3, 2, 1. And I didn't fill the tanks. All right, so that's one area that will just revert the flight. Hey, comedy is part of this channel. Again, lesson learned. I didn't check the fuel. I'd rather have not checked the fuel than not emptied the fuel. So revert the vehicle assembly like it never happened. And we'll bring the fuel back up and the thruster limit. As a matter of fact, we might put the thruster limit at 80. We don't need to go that fast to get over to the ocean. All right, so with that, now we'll save and now we'll launch. Our Kerbal's excited about that non-launch. Didn't take too much time. And here we go. Now I'm doing a little bit of steering here because of that goo container. And now I'm at a fast enough velocity where I didn't need to. And once I get to a certain amount, I'm going to deploy the parachute, create a little drag, and then as I come back down to Kerbal, it shouldn't take too long, so I won't speed it up. We're at 8,000 meters. That was a pretty good launch for 80% of the and there's where I came from. So as you can see, my trajectory is going to be directly in the sea or inlet. So we're good. We're on trajectory, exactly where we wanted to be. And the scientist has a little bit more experience piloting a spacecraft that he has no business piloting. But you know what? He's going to get us valuable science. So we're going to do this. Science is everything. We want to escape the atmosphere this episode, and that will be the pinnacle of this episode. Shouldn't be too much longer. I might speed it up here. And at 1,000, we're going to deploy our parachute. We'll come upright. We'll speed it up a little bit more. This is time speeding up. We're not actually going down that fast. And when we're landing in the ocean, of course, at sea level, we were 69 at launch. We're going to be at 0 because we're going to be at sea level. So here we go. Everything looks good. We're going to open the goo. And we're going to gather that data. And then we're going to look for our temperature. Open that, and we're going to log the temperature as well. And of course, Kerbal's water, temperature data collected from the environment. We got a little bit of science there. Let's see if it was enough. So we're going to recover the vessel and the pilot, well, and the scientist. And let's see what happens. So we got about 8 science, which should put us at the next level for that survivability. Our parts mostly recovered, so that's great. And then our crew gained 1 experience. So we'll hit done. We got some recognition there too. All right, so with that said, we're gonna go over to the R&D. We need survivability because survivability gives us the heat shield and a couple other pressure barometers, which is science, need science stuff. We got a landing strut if we wanted to, and we got a parachute, side deploying parachute. We have a service bay to keep our science in, and we have a comms tech level 2. So that's pretty good. That means we have a little bit more range, but we're not going to be able to use it until we have a little bit more battery backup. And of course, we have some radiators for heat dispersion. So, but we're not going to be using those radiators just yet. All right, so with that brings us to 3.5 science. That's not going to get us much anywhere. We'll go back in. We're going to look. I'm going to pick Orbit Kerbal because there's only a certain amount of time you can pick it. It expires in 2 days, 23 hours. So once I leave the atmosphere, I'll have 1 slot. I can always upgrade the command, the center here, the mission control, but in doing that will limit my funds, so I have to really balance the budget. So I'm going to accept this, and we're going to go back out, go right back into design. And as you saw with this design, the weight really shifted, and I had to adjust for that weight until I got up to speed. If I didn't, it would have put me into a tumble, and solid rocket fuels and tumbles don't mix well. So what we're going to do is we're going to get rid of the flea. We're going to keep the temperature, keep the goo, and we're going to add the barometer. Space is a vacuum, right? Let's test that theory. So here we go. All right. So again, science is king. We need science to perpetuate our next evolution of spacecraft. And I believe as a program manager, you want to try for as many patents as possible, but you also want to use as much technology in the marketplace, right? That will get if you have a crew, get your crew there safely. If you're automated, get your spacecraft there safely and with proper automation. And in the early stages, we don't have much here. What we can do, if I wanted to, is balance this out. Put another mystery goo container on the opposite side, so at least we have a balance point. Maybe even put 3, but no need. What we might do is an EVA when we get out there, because that gives us a little bit. I'll probably save the EVA for a later mission, more than likely orbiting Kerbal. So let's see what kind of things. We definitely need a heat shield, so let's go down to the heat shield area. Thermal. We have a couple different ones. We have a 0.625 meter heat shield. We have a 1.25 meter heat shield, and we have a procedural heat shield. This one's from a mod. It has potential upgrades. I don't need it right now, and it costs 300. All of them. The 150 is just too small, as you can see here. It's very, very small compared to the actual capsule. So don't need that one. I'll probably use that for some science gathering. But for our Kerbal, we want to keep him safe. And as a matter of fact, before we forget, we're going to go through our checklist early, and we're going to put Heidemarie Becker back in the pilot seat. And we'll go back to our build. So now, so far, our capsule is going to have an SAS, so we'll be able to compensate for that goo for pitch and yaw. And what we're going to also do is put an engine, or I'm sorry, decoupler first. We want to decouple this, and pushing the capsule from the rocket may be a good idea, or we can turn this, there we go, to a downward. So now we're pushing the engine away from the capsule. Now in space, that's important. When we get to no atmosphere, if we are in atmosphere, not so much. So as a matter of fact, I'm going to keep it pointed up. And then we're going to pick our engines. And the hammer is a really nice one, but it's not going to get us there. So what we might want to do, we might want to two-stage rocket this. The procedural has, and here's where the thrust comes into importance. All right, we have a max thrust on this procedural of 230, and that's at sea level, so it'll get us off the launch pad fairly well. But again, we're going to look at this thrust to torque and TWR, thrust to weight ratio, to see what kind of speed we're going to get at liftoff. We have solid fuel, and it's going to last for, let's see, that doesn't give us in seconds. So let's see, this is 1392.91 versus 400 and 200. So a two-stage rocket at this point would be better than the procedural. But this one, all right, so procedural SRB has 230 at sea level. The hammer has 197 at sea level. And the procedural is an overall better rocket. It's also more expensive. So what we want to do is escape the atmosphere. We're not going to go into orbit, so we don't want to over-engineer this, right? We want to engineer it for what the mission is. And as a program manager, you have to really rein in great ideas, move them into a buffer, so to speak, and keep them, explore them down the line. Here, I don't have as much money as I'd like. This will give me a lot more. So what we're going to do is we're going to do the hammer and see what my thrust to weight ratio is. It's 4.69, which is huge. Usually to get out of the atmosphere, you want 2 to 3, and that's on Kerbal. And it's going to burn for 23.7 seconds. So that's great. But we want to also keep this thing aligned. So we have fins. What is this going to do for us? This is going to stabilize us. So what we're going to do is we're going to look at what 3 fins will do for, you have 3 different aspects. You have the aerodynamics of the system. You have the center of gravity, center of thrust overlay, and then the center of mass. Yellow is center of mass, and as you can see, the aerodynamic overlay is what we're looking for to make this thing fly fairly good. And what I've learned in Kerbal, and might be true in actual, is you want the aerodynamics to be just behind the center of mass. That gives you a little lift if you ever go to the side. 3 fins will do that. If I reduced it by 1 fin, let me show you how that works. Or 2 fins, excuse me. 2 fins, you notice how I don't get as much movement from the blue ball, which is the aerodynamic overlay. So again, that we want that aerodynamic overlay. We want that below we don't want it in the center. We want it below the center of mass. So that was with 2. With 3, I don't need to exaggerate so much on the placement. And if we wanted to, this will sit on the pad fairly good right now. As we get into other aspects, we might want to do the micro landing struts to give us a little bit more lift, so to speak, or off the launch pad, that is. Now we're going to definitely be using these with missions that land on the moon or similar aspects to them, but for here, don't think we need them, and it'll rest on its hosel. We have enough thrust to weight ratio, and our order of our staging is the rocket, which is good because we have an automated staging spacebar, if you will. And then, of course, we have the decoupler. We'll decouple as when the first stage or second stage, when the second stage goes away, sorry, I don't mean goes away. When it stops its acceleration and it's expended its fuel, we will detach it. Otherwise, it'll just drag. We want to make we want to break that atmosphere with some style. So we don't want to just break the atmosphere. We want to hopefully go to at least 200,000 meters would be nice. Let's see what happens. So we have the decoupler on the second stage, the first stage, and of course the parachute. I won't change any of the settings for this, although I could change any one of these settings. Right now the force percent on the decoupler is 100%. I can vary that. And if I wanted to change the colors on this mission, and of course we're going to leave the atmosphere 1. And let's see what happens. All right, so we went through our checklist. Our pilot is in the pilot seat. We should be able to turn on our SAS. We should be able to get some science. We're going to turn on the RCS and the SAS. The RCS is going to be important in orbit. Right now we're at 70 meters. All our staging is go. Our stage green is go. And we're looking at our delta V stats, and I'll put them in my view. As we get the stability assist more advanced, we're going to have more selectors of the stability exist. Right now it's just straight up, and we might just deviate just a pinch when we get up to about 8,000 meters. All right, looks like our Kerbal is ready, and here we go. We're pretty stable even with that offset mass, and it's kind of dragging us to that side, which is fine. We're gonna tip it a little bit. G-forces aren't too bad for the Kerbal. If we were gonna go into orbit at 8,000, I'd start trimming more. Okay, the coupler went. Oh, we're still being pushed by the rocket. So the coupler went. Let's see if we hit to our map. Will we get high enough? We'll get to 11,000 meters. So that is not going to be high enough. We're going to revert the flight. That should have been high enough. All right. So this rocket, although it has a great amount of thrust, 23 seconds to burn to get out of the atmosphere was not enough. So lesson learned. What do? Well, we might want to do a 2-stage rocket. So let me take off the lower end. We still have the decoupler on there. Let's put the procedural there. And let's see what this thing has. So we have a lot of different selectors. Some of it's game type, others sort of real world. So you can do a little bit more customizing on the type of visual you'd want to see on there. All right, now this one, like we said, this is going to last 31 seconds. So let's think about that. We have thrust to weight ratio, which is greater than the hammer, but we're still at 31 seconds. We went 23 seconds and we went 11,000 meters. So like in any technical position, you want to be able to look at the burn rate of each individual, do some math, and say, we're going to put this aside and we're going to do a 2-stage rocket. In the past, I believe it was a 2-stage rocket that actually did exactly what we need to do, which is break the atmosphere. So we'll use the between the masses of the procedural SRB and the RT10. I'm going to use the RT10 as the second stage, put the decoupler, and then so basically we have a ballistic missile, or one that looks very much like it. All right, so this staging will not work for us. So as in Kerbal, we're going to do our checks. We have a stage we need to add. All right, so this is our 4th stage. Then we decouple our 4th stage. We fire our 2nd stage. So we're going to decouple and fire at the same time. That'll push the 3rd stage out away from the spacecraft, so we don't have any means of hitting ourselves. We also have the decoupler to come back to let loose the RT10, so we have a little bit more escape velocity with the capsule. We want to check out our mass overlay and our aerodynamics overlay because we're needing fins. Let's see. If we did 3 fins, that should give us plenty of stability. Again, you want to get this just right. I like to get it so we're just behind the center mass, and that should be fine for us. And as a matter of fact, in the physics of this world, this should sit on the landing pad fairly well. When we look at our engineer, because now we're starting to get up into, like I had mentioned, we have 13 parts. We're at 8.74 tons. So we're still underneath our maximums before we have to purchase. We have our height and our weight. Right now our height's 8.3 meters. So again, all the ones to the right of the slash are going to be the height or the maximum, the allowables, and the ones to the left are the actuals. All right, one more time. We have a pilot. Yes, we have a pilot. Checklist going on. We have 3rd stage, highlighted green, fires first. We have the 2nd stage going at the same time, so we're going to decouple and fire the 2nd stage of the rocket. And then we have the last stage decoupled. Now we have 54 seconds, say 55 seconds worth of burn. Each stage is going to give us a different thrust to weight ratio, and right now they don't look too bad, and we can look at each individual stage if we wanted to. So let's try this one and let's see where it goes. Oh, just one last comment. We're spending 6,189 on this. We have 177,434. We'll cover a lot of these, but we're not going to cover the all of them, and you'll see that on the lists, the manifest that comes up at the end of the mission. We're going to save this design because we're leave the atmosphere 1, and let's see the description. Simply to leave the Atmos and return safely. Again, mission statement, right? Very important. We don't want to over design. Do we want to get a little bit of science on the way? Absolutely, because space, there's going to be a lot of science we can gather from this mission, so we're going to do it. And we're going to get a launch pad. Okay, we are settled in. We're going to do our checklist again, turn on our SAS because we have a pilot in the pilot seat. We verify our checklist again. We have 3rd stage, okay. 2nd stage, okay. 1st stage, okay. And the parachute. In the later game, we're gonna have all our science able to be not necessarily staged, but there's gonna be short keys, which is gonna be nice. we won't have to right click on them to do the science. Right now we have our checklist and we're ready to launch. 3, 2, 1. All right, so we're going at a good clip, not a great clip. And why I said that was I'm monitoring the speed because we're trying to get to a certain speed. Because of the weight, we slowed down off the pad just a little bit. We're starting to get some air drag, although not too bad for this type of capsule with exposed scientific experiments. At about 8,000, I am going to start turning the vessel. In the lower left corner, we have... Oh, I oversteered. That's my fault. I don't think we'll make it. So that first stage got us to 11,000. The second stage, the fuel is going down pretty fast. Maybe we might be able to do it. Right now we're gonna go quite a bit. Let that eject when it has a moment. It's still pushing the capsule. Let's see how far we're gonna go up. We need at least 70,000. So we're not gonna make it. So a 2-stage rocket didn't make it. So lesson learned there. I thought we would have enough. Maybe a 2-stage rocket. Let's see. Let us go back to the drawing board. All right, we'll keep all this. The overall aerodynamics and center of gravity, that worked well, so I want to keep that. What we'll do is we'll take the bottom off, we'll take the R10 off, we'll spend a little bit more money, and we'll do 2 of the SRBs. We'll stage them. Now, I think this is a glitch with the program. Let's I'll spend a little bit more money because I think we have to use, well, we don't have to use it, but I'm going to use the procedural decoupler. And let's see what that gives us. We have diameter, sides, plain metal, ends. So more enable to crossfeed. That enable crossfeed means we're going to pump fuel from one engine to another. So in this case, it's solid rocket. We don't need to do that. And we can recolor it. That's more of a game function. We look back at our checklist. We want to move our decoupler. All right, so now we have 62.8 seconds worth of thrust. Our thrust to weight ratio is still 4.99, which is really nice. We have a 2.84 on the second stage. So I'm thinking a 2-stage rocket will do what we want it to do. So let's save this configuration because the other 2 were not as good. And as a program manager, you really have to assess the differences in the project, right? What happened prior? Lessons learned. What can you modify to get a better project? One more time for the checklist. Stage. We're going stage 3, we're going stage 2, we're going stage 1, and we have a parachute. And the parachute, if I was going to take all this back down, I would probably have this laden with parachutes. But I don't need all that, so here we go. Let's see what happens. And here's our stats, our delta V stats. So it allows us to see what's performing at what. We should get about 2,000 meters a second by the second stage, which will be perfect. Again, looking for that 8,000 meter sweet spot. and looking at the solid fuel as it starts to exhaust. We want to be able to decouple fairly quickly. Give it a little angle. Give it a little bit more angle. And the angle is going to give us a couple things. It'll give us a little bit more drag on the top, but it'll also allow us to see the arc of our orbit, or what it potentially could be. And it'll allow us to decouple a little bit easier. So now we're up at almost where G-forces are coming up. We're coming up on almost 2,000, and something failed. So what failed? Our goo failed. So there's a lesson learned right there, huh? The G-forces hit, the thermals hit at such a high rate that our goo failed. But as you can see, our apoapsis is going to be 315, 288 meters, 315,288 meters, which puts us in space. So this is great news for us. And hopefully we'll shake this booster. And at this time, we're at 100,000. I'm going to run some tests. We're going to log that temperature. Got 8 science because we're in space. We got 12 science from that one, so I really need to recover this, and I'll bring goo back up. And of course, with the Kerbal, we can't do an EVA just yet, but in our next one, we will. So cannot disembark while off Kerbal service, and that's because we don't have the science right now. We need the astronaut complex upgrade to get the proper suit to do so. All right, so we have our science. We're gonna speed it up a little bit because we're gonna have to go to 315,000. So in space, you're gonna be able to do a little bit more. And as you see, we're starting to pitch back down. So once we get back down, for some reason our decouple did not work. This is not gonna be good. Let's see if we can shake it. It did not shake. So our decoupler failed. So this becomes an emergency mission right now, and we're going to have to do some interesting engineering and manipulation to come back down into the atmosphere. Another anticipation that I should have had as a program manager. What happens if our decoupler fails? And in this scenario, we're going to have to wait and see how much heat this rocket, the SRB, will be able to take, and see what happens. We have no fuel, so we shouldn't see an explosion, which is good. I'm still curious why that decoupler did not decouple. Not happy about that. It's right there too. TD12 did not decouple. All right, so we're heading back down. A little space. Awesome site for the Kerbal. As a matter of fact, I'm going to take a crew report while we're up here. Get a little bit more science. Pan out a little bit. Let's see the universe. The planet below us. Awesome. Just awesome. First person in Kerbal space history right here. And they already have a problem, so looks like they're going to be headed to let's see, let's get a map. I need to know where they're landing. So they're landing on the dark side. And they're gonna miss landfall. Okay, so we're back over on this. We're gonna pitch. What we want is this reticule here. We want to align with it, and that gives us the actual perfect adjustment for our capsule and our rocket to come back into re-entry. Again, this is going to get bumpy. It's kind of exciting. Now, in certain game terms, I could just relaunch and get a better decoupler in there, right? But for this type of... this is pretty cool, actually. Let's see what happens. We might end up losing the capsule as well, depending, because we're coming in at about 1,800 meters a second, and we're not going to be able to slow down at all. And that's mostly because we have the mass of the rocket attached to the capsule, which wouldn't happen normally, and the capsule would come back down fairly decently. So I got to keep the capsule in that yellow reticule, and that'll help with the engine, hopefully. And we just flipped, and I had no control over it, which means all our heat is coming down. I think some of our experiments just got destroyed, so we get no science. So failure on a lot of different fronts. Let's see if we can... I deployed the chute so I can move while we're in the surface safe zone, and we're at 4,000 meters. We're gonna get hopefully a successful landing. Let's see how fast we're going to drop here at 1,000. This is now it's really, we achieved what we wanted to achieve, but we really want to save our astronaut. Let's see how fast we go. Remember, the capsule is at 14 meters a second. We're at 7.3, 7.4. So we might just land okay. We just lost all our science except for our crew report. So we'll speed it up just a little bit. Time's speeding up, and then we'll take it down to normal time warp, which is normal time. And let's see what happens. We're gonna... Alright. So that's good news. That's really good news. So we're gonna recover this one, even though we didn't achieve the science mission. We will be able to do that again. That's a small price to pay for the Kerbal life that saved, and this rocket that we're going to recover will help us a little bit as well to figure out. And we didn't expend the cost of the decoupler, which is a ruined decoupler anyway. But we'll do a lessons learned. We recovered the vessel. We'll come back to Kerbal, and we'll see what happens. So we did get 5 science from the report, and the recovery of the suborbital flight gives us 8. So that's awesome. And then, of course, the parts and the crew. She gained 1 experience for that. That's awesome. Well done. 55 reputation because we completed the mission. And we recovered quite a few things, actually. We got some monopropellant left, which is, hey, savings is savings, right? Of course, our solid rocket fuel is gone. Our ablator was saved because we didn't use it. Wow, that was, I'd say, an overall successful mission, even though we failed on the science, and partly we failed on the decouple of the first stage. So we'll have to go back to the drawing board on that and find out why that occurred. And what I want to do now is go back to science. We have 31. We have stability, and we have general rocketry. So if we go to general rocketry, we could spend 20 and get better systems like the Thumper, which will help us get into orbit. We have the fuel tank, a liquid fuel tank, the FL2000 or T200, and of course we have the procedural tank, and we have another procedural SRB. So this might be, basic rocketry might be where we're going to go. Stability is just that. It's going to give us a better wing, a radial decoupler, which will help us in future missions, but for now, and with the radial decoupler, you'll need the procedural nose cones and the aerodynamic nose cone to put on the rockets that are aside your capsule, because the aerodynamics will change. So what we're gonna do is we're gonna go with general rocketry. We might run another mission like that, just to get the science back that we missed. We might try for orbit, but let's see what other missions we have as well. So I'm going to grab the rocketry resource of rocketry science. Go to mission control. We only have one active mission, which is orbit. And we have a couple different missions here that will give us a, well, you know what? I'm going to take this one. It's one science. But just reading it, it's the TT-38K radial decoupler at the launch site. It'll give me access to the radial decoupler for the test. And you know what? I need another decoupler. I'm very upset at the failure of the other decoupler. And what I would do as a program manager is the mission was a success, but not entirely. I would need to go through with the team and say, have a lessons learned and find out, discover why that decoupler did not perform as intended. So we're gonna grab this, and then we're gonna go back out here, and we're gonna close this episode out. That was exciting at the end there. I had no idea whether we'd come back or not. The two SRBs got us to 315,000 feet or meters, which will in Kerbal will mean we might be able to use a 2 to 3 stage rocket to get us into orbit. It's going to be interesting in the next design, but we've learned a lot from the 3 designs here to get us out of the atmosphere in the first place. So everything we've encountered is great. We have 291,000 Kerbal dollars, and the launch pad is going to have to be upgraded. Right now we can upgrade it for 50,000, and the max size goes up to 36 meters and 140 tons. To do a launch for an orbit, I'm going to go ahead and upgrade it. And then for the astronaut complex, it's 75,000, and that gives us 5 active Kerbals and can disembark only on Kerbin. So it's going to take a couple upgrades to be able to actually do an EVA. But I don't know if this is worth it for me right now at 75,000. Upgrading mission controls 75,000. So there's 2 there that may be worth it. We can't upgrade our science. Our limit's 100. The upgrade would be way too expensive at this point in time. And the administration building upgrade is 150. And that gives us the active strategies. As a matter of fact, I'm going to look at the active strategies real quick before we sign out. And I'm going to see what it would give us. So for 11 science, which would cost us all our science, we'd get another 598,000 funds. That is tempting. What could we do with that? So if I did it in half and spent only 6 science, I get 300,000 funds. 6 science. That's something to think about for next episode. With that, thanks for joining me. And I hope everybody learned a little bit about more program management and a little bit more about Kerbal and had an exciting time there at the end. Very cool. If you haven't already, please like and subscribe. You'll be able to get weekly updates when we come out with the series on YouTube. And I do post to Odyssey and Rumble. And I'm looking to post on BitChute as well. So just a few different platforms to save my work on. And with that, have a great time learning. I hope everybody keeps looking up.